It's called the facial nerve because it provides innervation to the muscles of facial expression. You know by the rule of fours that it exits from the pons. In fact, the cranial nerves exit in order.
I noticed that on last
So
chapter.
2, 3, 4, 5. Here's 6. Right next to it, 7 and 8. Okay. We said that if we group any cranial nerve, 7 and 8 are usually grouped together because as it leaves, it enters into the internal acoustic meatus. Now, 7 and 8 go in together. They're like besties. 8 doesn't come out. Why? Because the
It's
inner
like a
ear
horror
is
story.
located within the petrous portion of the temporal bone. 7 continues through the petrous portion and exits the skull through the stylomastoid foramen. You remember that, don't you? Between the mastoid process and the styloid process. And as it exits, the first thing it encounters is the parotid gland.
It just disappears. We were having a really important discussion.
So as it exits the stylomastoid foramen, it passes through the parotid gland.
Is that Red Fred's head?
Huh?
Is that Red Fred's head, or is that just
That's
a
Red
random
Fred's
friend?
head.
Oh.
You can take that off?
Yes.
Okay.
You can
As
take
it's
anything off
passing
of
through
Red
the
Fred.
parotid gland, it branches. Okay, and these various branches provide innervation to the muscles of facial expression. It's a mixed nerve. It's going to carry both motor and sensory fibers. Besides somatic motor fibers, it carries parasympathetic, autonomic, and visceral motor fibers to the lacrimal gland and 2 of the 3 major extrinsic salivary glands, sublingual and submandibular. So, let's look at this. Here's the 3 major extrinsic salivary glands. When we say extrinsic, we mean they're located outside of the oral cavity. The largest is the parotid. Here's the parotid duct that's carrying the secretions to the oral cavity. Here's the submandibular. It's called submandibular because it's located under the mandible. And then look over here. Here's the sublingual. So, the 7th nerve provides innervation to the sublingual and submandibular. Here's the kicker. Even though it passes through the parotid, it doesn't innervate it. Isn't that ironic? Don't you think?
I think it's very strange.
Yeah. Jacob, why are you smiling?
No.
Song?
No, I don't have anything.
A song?
I'm just not.
Alanis Morissette? Isn't it ironic? Don't you think?
I think Jake just smiles to get him through this class.
That's right.
That's that. We all. Hey, I'm like that too. I'm just trying to get through.
It kind of looks like you're having fun up there, but okay.
Okay.
I'm not having fun.
So no. The idea is that 7 passes through the parotid, but it doesn't innervate it. But it does innervate the submandibular and sublingual. The 7th nerve also provides autonomic innervation to the lacrimal glands, which allow you to cry or lacrimate. Now, these are all motor functions. The sensory function is for taste to the anterior 2/3 of the tongue. So we can say that the 7th nerve tastes, salivates, and lacrimates. I repeat, second verse, same as the first. The 7th nerve tastes, salivates, and lacrimates. Okay? Here we see the 7th nerve passing through the parotid gland and branching. And these various branches are innervating important muscles. Okay? I'm going to mention 2 of the muscles of the face to get us through this nerve. Do you see this muscle that encircles the orbit? This is a sphincter muscle. A sphincter muscle is one that encircles an opening. And when it contracts, that opening closes. Okay? This sphincter muscle surrounding the orbit is called the orbicularis oculi.
It's fun to spell.
Orbicularis oculi, and that terminal I is always possessive, meaning of the eye. So orbiter of the eye. When this muscle contracts, it closes the eye. Hence, at the beginning of the class, I said that 3 opens and 7 closes. Okay. These 2 muscles here, these originate from the zygomatic bone. So we're going to call these 2 muscles zygomaticus. We have a zygomaticus major, that's the bigger one, and a zygomaticus minor, it's the smaller one. Now, they insert upon the corner of the mouth, okay, to lift up the corners, as when you smile. Okay? If you want to demonstrate the function of the zygomaticus, have somebody like Jordan take a big old smile.
I'm good.
Can you do that for us?
No.
Just lift up your chin, smile. Okay, that's it. That's it. And when she smiles like that,
I don't like smiling.
it accentuates those nasolabial folds. Okay.
Wait, I'm sorry. So the major and the minor are the muscles that it
That
controls?
insert upon the corners of the mouth, they lift up the corners so that when you smile, it brings them up higher. And it accentuates those little folds here between the nose and the mouth. That's an important concept, by the way. Like growing up, you probably all noticed those folds, but you didn't give them a name. As a child, when your parent was teaching you eyes, nose, mouth, nobody pointed over here and said nasolabial folds, but they're important.
Sarah, make sure you do that with slime.
I feel like you and Dr. Weiser would have done that.
Yes.
So you did.
Did y'all really?
Yeah.
I would have if I were y'all.
Okay.
I knew what the name was.
All right, so here's a cadaver. And this is the parotid gland. And you can see emanated from it are all these branches of the facial nerve. Number 11 here is the orbicularis oculi. Okay, here you can pick up the zygomaticus major and minor. What is this muscle here?
The mandibular. Oh no, that's the nose. What do you think?
It's got to be something with the jaw.
Right, it's the masseter. It's a muscle of mastication. So, whereas the 7th nerve innervates all the facial muscles, including the orbicularis oculi and the zygomaticus muscle, it does not innervate the masseter.
Yeah, that's 5.
That would be 5.
Catching one.
Good, you're doing well.
Thanks.
All right, now, for the next 10 minutes, it's going to get a little hairy.
Oh God.
So, put on your thinking caps and hang on. It's going to get a little bumpy. Of everything I said so far, for some of you, what I'm going to say next is going to be the most difficult. You say more difficult than these hemianopsias?
You have me nervous now. Because today's been like an easy breezy class, I feel like.
Cover girl.
They have literally so many cover girls. Have y'all like, they have Pink, Sofia Vergara, Ellen.
Everyone's a cover girl. 2 pieces.
Yeah.
Probably.
I think once you are, you're like you never are not.
Carrie Underwood.
That would be offensive if they took that title away from you. What's stupid? Oh.
It's always like the
Sure.
smoky eye one. It's like blue all over her face. And it just doesn't.
So you like the basic makeup
I don't wear blue eyeshadow.
on the reg? Yeah. He never leaves the school.
He literally
Yeah, Cody.
I don't know anything.
You're too good.
No, I just don't, I'm not good with names. Good with faces.
You all right, Cody? You need anything, let me know. I'm going to draw in the motor nuclei of the seventh nerve. Okay?
Here we
In fact,
go.
I'm drawing two representative lower motor neurons within that nucleus. I know it's in pond, so I'm drawing the nucleus right here. Okay? Now, some of these lower motor neurons are going to provide innervation to the upper face. Some of these lower motor neurons are going to provide innervation to the lower face. Everyone understands what I'm doing here?
Yes.
Yes.
Okay. The somatic motor pathway for the lower face, okay, has upper motor neurons that are contralateral. This is the lower face. So the upper motor neuron innervation to the lower face is contralateral. It decussates, these neurons decussate. By the way, these upper motor neurons to cranial nerve nuclei travel in tracts, but they're not cortical spinal tracts because they don't reach the spinal cord. These tracts carrying these axons of upper motor neurons to cranial nerve nuclei, these are called cortical bulbar. As opposed to cortical spinal. Now, the upper motor neuron innervation to the upper face is bilateral. In other words, you have some upper motor neurons that are from the contralateral hemisphere, and some that are ipsilateral. Okay, so I'm going to repeat. The upper motor neuron innervation to the lower face is contralateral. The upper motor neuron innervation to the upper face is bilateral. So these neurons that are serving the muscles of the upper face, okay, these lower motor neurons receive bilateral upper motor neuron innervation. And that's going to be important in terms of the clinical presentation of patients. I'm going to give an example. A very common problem with the seventh nerve is a condition called Bell's palsy. Have you ever heard of that?
I think I have.
Yeah, it's caused by a viral infection of the seventh nerve. It affects the nerve here. So it's going to cause damage or injury to lower motor neurons to both the upper and lower face. So let's look at the upper face. If you have lower motor neuron damage involving the right seventh nerve, is that person going to be able to lift up their lid?
Yes.
Yes, because that's third.
Right.
But will they be able to close that lid?
No.
No. So if you ask this person to close their eyes tightly, they'll close the other eye tight. And in fact, it'll cause some wrinkling around the eye. But they won't be able to close this eye.
Like gravity won't they.
No.
Okay.
No. And in fact, in terms of wrinkling their forehead, they can wrinkle the left side, but not the right. Because that muscle, the frontalis muscle, is also innervated by 7. If they lose the function of the right seventh nerve, what do you think is going to happen to the corner of this mouth here?
I'm gonna droop.
Droop, and then it will start to drool. And there's going to be attenuation of that right nasolabial fold. So they're not going to be symmetrical. Okay, so we'd call this, and by the way, this eye is going to be dry. Why? Because the seventh nerve innervates also the lacrimal gland.
Right.
All right, so we would call this a dense hemifacial paralysis. It means it involves the entire half of the face pretty densely with a lower motor neuron lesion. Now, I mentioned one type of lower motor neuron deficit, a Bell's palsy. If you had a brainstem stroke that involved the seventh nerve nucleus, you'd have the same result, a dense hemifacial weakness. By the way, if you're an adult that develops a Bell's palsy, what are you going to do to prevent the eye from drying out?
Drops.
Drops.
Drops are more often an ointment, like Lacrolube, and you have to put it in every 2 to 4 hours.
Oh, that's like the worst.
If it's a child for which that becomes difficult, you sew the eyelids. You just do this, sew them together, so they can't open the eye. The good news about a Bell's palsy, of course, is that over the course of a month or two, it tends to resolve in most people. Some people are left with a deficit. Now, let's compare that to an upper motor neuron lesion. Let's go back and let's start from the get-go
Bless
one
you.
more time.
Oh, we should have said mustard.
Control your nostrils.
Let's start from the get-go. Okay. Let's say this person has a stroke involving the primary motor cortex in the area that controls the muscles of facial expression. Okay. Now, as a result, because the pathway, the somatic motor pathway to the lower face, only involves contralateral upper motor neurons, if you knock out those upper motor